Hi, in this video we're going to be doing a review about bases. Now strong bases, like strong acids, 100% dissociates in water, dissociates completely in water. And so if we want to find the pH of a strong base like KOH, what is the pH? We're just going to use the molar we're given. So let's say we're given with 2.8 molar of KOH. So what is going to be the pH? Well, the pH is going to be... Now, if we use the negative log of this 2.8, it will give us not the pH, but the POH, because we're dealing with the base. So this equals POH. And POH plus pH equals 14. So you can do 14 minus negative log of 2.8, which is aka 14 plus log of pH. So our pH is going to be 14 minus negative log of 2.8, which is technically a plus. Now if we're going to do that, 14 plus log of 2.8 will give us a pH of 14.45. Now, although this is beyond the pH scale of 14, the answer is still correct. There are acidic and basic properties that go beyond the pH chart. So just be aware, 14.45 is the correct answer. Now on the side, I'm going to draw the process of what happens. Okay, KOH turns, 100 dissociate completely, so it's going to be a single arrow plus OH minus. Dissociation complete means everything is used up. So we have 2.8 to start with and minus 2.8, which will equal to 0. These two start with 0, so this will be plus 2.8. Plus 2.8. So we'll end up with 2.8 molar of OH minus. And this is why you plug it in over here to get the POH. And then from the POH, we can get the pH. Now, similar to acids, weak bases, we're going to use Kb. So for weak bases, our first step is going to be find Kb. So let's say we have find the pH of a 3.5 molar solution of N2H4. Now let's first write the equation. All right, N2H4 plus H2O. Since this is a base, this is acid, this will be donating to N2H5 plus OH minus. Now I have 3.5 minus X. It's gonna be, we're gonna cross this out. It's gonna be 0, 0 plus X. It's gonna be 3.5 minus X. This over here is gonna be X and X. So Kb, because we have a base as the product, and we have a, because our reactants it's a base. Now because we're producing a base as a product, we're going to be using Kb, which is going to be equal to X squared divided by 3.5 minus X. Kb can be found by using the Ka of the conjugate acid. N2H4's conjugate acid is N2H5 plus, and N2H5 plus's Ka is given at 8.3 times 10 to the negative 9th power. Now, Ka times Kb is equal to 1.0 times 10 to the negative 14th power. So now we have Kb, now we have Ka, we can simply divide both sides by Ka to cancel this out and get our Kb. So let's quickly go to our calculator. 1.0 e to the negative 14th divided by 8.3 e to the negative 9th, which gives us Kb is equal to 1.2 times 10 to the negative 6. Now, because this is a very small Kb, is less than 1.0 times 10 to the negative 4, this minus X can be ignored. Now we can just do 1.2 e to the negative 6 times 3.5 and take the square root of that, and we'll get X as equal to 0.0065. Now, what is X? X is the concentration of OH minus. POH is equal to the negative log of the concentration of OH minus. So we can find pH by using 14 plus the log of 0.0065. And when we do that, 14 plus log 0.0065, it will give us a pH of 11.81. Some anions can make solutions basic. For example, let's see, NaCN, when NaCN is added to water. First, NaCN will turn into Na plus Cl minus. Na, since it's plus, it can combine with NaOH, and NaOH is a strong base, so Na is going to be a weak conjugate acid, which means we don't include this. Oh, this is not a Cl, this is Cn. Cn, when we add it to a H, when we form HCN, it is not a strong acid, which means this is going to be a strong conjugate base. And since it's a strong conjugate base, we can apply, it will form a reaction with water, H2O, which will form HCN. Since this is the base and this is acid, it will be donating. It will form HCN plus OH minus. Now, since we have OH minus, that means the pH is going to increase. Any conjugate base of strong acid will not raise the pH of a solution. These conjugate bases are unable to keep H plus in water because strong acids go to completion. And these conjugate bases are Br minus, HSO4 minus, Cl minus, ClO4 minus, I minus, and NO3 minus. So these conjugate bases will not raise the pH of a solution. And finally, metal oxides make solutions basic. Metal oxides make solutions basic. For example, CaO, we have this solid metal oxide, and this will form Ca2 plus O2 minus. Now, this O2 minus will be able to react with water plus H2O liquid to form 2OH minus. So, when we have CaO plus H2O, what will happen is it's going to be Ca2 plus from over here, and this O2, which is produced over here, will be used over here, combining with H2O to form OH minus. So this will be plus 2OH minus, aqueous, which is why metal oxides increase the pH. Thank you for watching.